Okay. So now the problem with the classful address. Okay. Problems or issues with classful address. Let's try to understand that. Issues of classful address mask. Okay. Classful address mask. The problem with classful address mask was that, let's say a company, okay, a company has, for example, let's say 500 employees. Okay. For example, he has only 500 employees. Okay. And he comes to an ISP and he says, I want my employees to be connected to the internet. That means I need 500 IP addresses. Okay. And all the IP addresses should start with 10, for example. It should start with 10. Okay. So as an ISP, you have two information. You need 500 IP addresses and the IP address should start with 10. So if the IP address needs to start with 10, you need a class A IP address, right? And we know that in class A, we have one network octet, and we have three host octets. Right? This is what we have learned. So 10, he wants 10 to be the starting of the IP address. So your network octet is constant. Any IP address 10.1.2.3 can be given to one of the employees. Okay, 10 dot, for example, 400, not 400, sorry, 200.200.200 can also be given to one of the 500 employees. Okay, however, however, we have three host octets. Okay, we have three host octets. Three host octet means that, okay, how many bits are there? There are 24 host bits. There are 24 host bits, meaning that an IP address can be either when I say 24 host bits, meaning that starting from the second octet till the last octet. Okay, there are 24 bits of IP address, 24 bits. So that means one bit is either one or zero. Okay, that means if you have 24 host bits, that means you can have 2 power 24, 2 power 24 combinations of IP address, which is far, far, far beyond what the customer asked for. Customer asked for 500 employees. Okay. And he said, I want the IP address to start with 10. We gave him that option. We said, okay, use this IP address. Use 10.0.0.0 address space. You use this address space. Okay. But we are also giving him the IP address for the 500 employees. And we're also giving him a lot many IP addresses that he is not going to use at all. Okay, that he is not going to use at all. So what is happening? The IP addresses are wasted. They're completely wasted. The other IP addresses, except those 500 IP addresses, are completely wasted. And please remember that once you assign an IP address space to an ISP or to a customer, you cannot reassign that IP address space to anyone else. So if this company or if this guy gets the IP address space of 10.0.0.0, okay, he owns this IP address. He owns this IP address, whereas he only needs 500 IP addresses plus he will use these 500 IP addresses plus he is also paying for these wasted IP addresses also. So what is happening? There is a problem. As a user, I am not going to get the IP address because this guy needs it. Okay. And it is completely wasted. So I will not, any other user except for the employees of this company will not be able to use that. So it's completely wasted. Obviously, 2 power 24, I think goes still around, even around crores. Okay. Where is a crore and where is a 500? Right. So crores of other IP addresses are basically wasted. You can give those IP addresses to other users who may be able to communicate on the internet, but no, you cannot, because it has been assigned to the customer. For this purpose only, we thought, why not just give the IP address that he wants, or the IP address space that he wants. Okay, so for example, instead of 500, he asked for example, he asked for 254 IP addresses. Example, okay, he asked for 254 IP addresses, right? So, and he said, I want the IP address to start with 10. Okay, so class A IP address again. He said, I want the IP addresses to start with 10 and I want 254 IP addresses. This is his requirement. Okay, now again, we'll go ahead with 10.0.0.0 IP address. However, the default mask is 255.0.0.0. We will say, I'm not going to give you this address mask. I will not give you this address mask. You use the address mask of a class C IP address, that is 255.255.255.0. This is your address mask for the IP address that you asked. With this, what is happening? Let's try to calculate the network ID, the usable IP address range, and the broadcast ID. What is going to be the network ID for this one? To find out the network ID, we know wherever there is 255, copy that value. So 10.0.0. This is 0, so 0. This is your network ID. Okay, and the broadcast ID would be 10.0.0. This is the 0 that we're talking about. So this will be 255. This is the broadcast ID. Now, any IP address between 10.0.0.1 up till 10.0.0.254 is the usable IP address range. So what is happening here? The customer wanted 254 IP addresses. We delivered 254 IP addresses without, and also he wanted the IP address to start with 10. So our two requirements of the customer is fulfilled, but we had to break a rule. This, he wanted a class A IP address, but we gave him an address mask of a class C IP address. Okay, this is what you call as subnetting, and in other words, classless IP address. Classless IP address, meaning that the class of IP address is not equivalent to the default address mask. Is not equivalent to the default address mask. That is basically what we call it as a classless IP address. All right. Now, meaning that I can write class A IP address, for example, 10.1.2.3 with an address mask of 255.255.0.0. This is a classless address mask. Again, 255.255.255. This is also a classless address mask. Class A IP address with a class B address mask and a class C address mask. Similarly, 198.168.1.1. This is a class C IP address. I can write this as 255.0.0.0 and 255.255.0.0 as well. A class A address mask and a class B address mask. This is also an example of a classless address mask. Okay, or another form of subnetting. Okay, so based on the requirement, I'm giving away the IP addresses and breaking the rule of the original classful IP address. That is basically what a subnetting means. All right. Now, with this, let's try to solve few questions on finding out the network ID and the broadcast ID. Okay, let's take that same example of 192.168.1.1. Okay, with a class B IP address mask, 255.255.0.0. Okay, what is going to be the network ID? We know wherever there is 255, copy that value down, 192.168, and wherever there is 0, write 0. This becomes your network ID. All right. And to find the broadcast ID, change the zeros to 255, 255.255. This is your broadcast ID. Okay. This is your broadcast ID. Right. Any IP address between this 192.168 starting from 0.1 up till 192.168.255.254. These are the usable IP addresses. Okay, this is for class B address mask. Similarly, if we go for a class C IP address mask 1.1, okay, with a class C IP address mask 255.0, network ID is going to be 192.168.1.0, and the broadcast ID is going to be 192.168.1.255. Any IP address .1, .2 till 254 are the usable IP address range. Okay, so for classless IP address mask, finding out the network ID and the broadcast ID is also very similar. All right. Now,
Here we can put 255.0.0.0 also, it will work.
where? Sorry, I did not understand.
In this one, this 192.168.1.1, you taken
Mhm.
once 255, 255, 0.0. Second one you taken 255, 255,
Sorry, sorry.
255, 0. Now if I do 255, 0.0.0 also will work.
Yeah, this will work. So the network ID here instead of this is going to be 192.0.0.0.
Okay. So then
Okay,
all will
network.
become
This will become 255.255.255.
oh, so number of hosts will increase here in this. So
Yeah, the number of
multiple
hosts will
to
increase.
to
Yes.
to the 24 it will go in this case.
Yes.
So any one of them can be applied. So either 255.0.0 or 255.255.0.0 or
Yeah.
255,
Class A, B, and
255.
class C. Exactly. That's what classless means. You don't have to follow the classful address mask. You don't have to give the default address mask for that respective number. And again, please understand the number is for us to understand, to classify based on our understanding. This is class A, class B, class C. Come networking devices, they do not know what is a network. They do not know what is a class first. They just know the number of ones denotes network ID, the number of zeros denote the host ID. That's all they understand. They don't know if it is a class A, class B, class C.
After
It
putting
is
this,
for
this
us.
doesn't matter also.
Yeah, exactly. After putting this also, it doesn't matter for us as well.
So if you do 10.9.9.9, that also will be, we can use this, all of the things, 255, 255, 0, 0,
10.9 dot,
10 dot, in this case also
yeah,
we can use the same thing, 255, 0.0.0, 255,
255,
255,
yeah,
0,
0 dot 0 dot 0, you can have this IP address, or you can
255,
have
255,
255 dot 255 dot 0 dot 0
0,
as well. You can have
or
255 dot 255 dot 255 dot 0 as well.
okay, anyone, depending on that, system will,
Depending on the
the device
requirement,
will,
not the system, depending on the requirement of the customer,
okay.
depending on
So,
the requirement of the
okay,
customer.
so mean how many employees there, how many systems I need, like that kind of thing,
Exactly,
then
exactly. How many employees are there? How many systems are there? Not just employees, how many residents are there? Okay, what's the area and how many users are there in the area? What IP address can I assign in this particular area, etc. Depending on all that.
okay.
Okay, you can use that particular IP address. Now, the problem with this is that it's very simple. In real time, you may not see this number at all. You may see this number. You may not see this number. You may see other numbers as well. Okay, for example, 10.1.2.3. Okay, the default address mask, or if I use a classless address IP, 255.255.0.0. You may not see such number. You may see something else, 255.240.0.0 as well. Or you may see 255.255.224.0, or you may see 255.128.0.0, or you may see 128.0.0.0 as well. Okay, so the address mask is not limited to only the number 255. You have other numbers as well. You have other numbers as well, other than 255. And those numbers are give me a minute, I'm trying to find that table. Yeah. So the other numbers that you may find in an address mask are these numbers, other than 255, 128, 192, 224, 240, 248, 252, 254, and 250. These are the only numbers that you will find in an address mask. So when I say you may find other numbers like 255.255 dot 224.0 like this, an IP address, or 255.192.0.0 like this as well. Or for example, you may also find 240.0.0.0 as well. You may find 255.255.255.252 address mask as well. You may find such address masks in real time network in your experience as well. Okay, you will find the default address mask of 255.255.255.0 like this as well. The simple address masks or the easy address masks. You will find these easy address masks as well. And you will also find these difficult address masks as well in real time network. Okay, now you may ask, why only these numbers? Why not any number in between? Any number between 0 and 128? Why cannot I have 255.1.0.0 as an address mask? Or why cannot I have 255 dot let me have some number 245.0.0? Or why cannot I have 255.255.255.30 like this? Why cannot I have a number like this? Why only these specific numbers? You may ask. The reason is that, as I said, the networking devices find out the network part of an IP address and the host part of an IP address by the number of ones in the address mask. Okay, I hope this is clear. The networking devices find out the network ID of an IP address and the host ID of an IP address to the number of ones in the address mask. Okay, please do not confuse between address mask and IP address. Okay, let's say 10.1.2.3. Okay, the default address mask is 255.0.0.0. So any networking device will find out which is the address, which is the network part and which is the host part of this particular IP address through the address mask only. And in the address mask, it finds out the number of ones: 1, 2, 3, 4, 5, 6, 7, 8. I'm not writing the whole zeros, 0, 0, 0. So it reads these 8 bits of ones in address mask, and it sees that it corresponds to the number 10 in IP address. That means this is the network part of that IP address. The rest of them are host part. Okay. Similarly, for 10.1.2.3, if I write the address mask as 255.255.0.0 for a classless IP address, a networking device will find out which is the network part. So 255.255 over here in the address mask correspond to the first 2 octets of the IP address, that is 10.1, and hence 10.1 is the network part and the rest of the octet is the host part of that IP address. Similarly, 10.1.2.3 with an IP address mask of 255.255.255.0. It thinks these 3 octets of the address mask correspond to the first 3 octets of the IP address 10.1.2. This is the network part, and the next part, which is 0, that corresponds to the host part. All right. Now, why is this important to understand? Because, as I said, based on the number of ones, it tries to identify which is the network part and which is the host part. And the placement of ones is extremely important to understand. The placement of one, please remember this statement: placement of ones in the address mask, placement of ones and zeros, I should say, placement of ones and zeros is very important for a networking device to understand which is the network part and which is the host part. So, so over here, if you see, for a class A IP address, this is the default address mask. And if you convert its address mask into the binary form, you will see all the ones are together and all the zeros are together. For a class B IP address, you can see all the ones are together, all the zeros are together. Similarly, for a class C, all the ones are together, all the zeros are together. So the condition of a writing an address mask, again, please remember the condition of writing the address mask is that all all ones should be on the left hand side of the address mask. You can see all the ones are left hand side, all the ones are left hand side, all the ones are left hand side, and all zeros should be on the right hand side. All zeros right hand side, all zeros right hand side, all zeros right hand side. That's condition number 1 for writing an address mask. All the ones in the address mask should be on left hand side, and all the zeros in an address mask should be on the right hand side. Again, I'm stressing on the word address mask, not the IP address. Address mask. IP addresses can be any number. It can be any number between 0 to 255 in an IP address. In an IP address, the number can be between 0 and 255. But for an address mask, the numbers that we choose, should have all the ones on the left hand side and all the zeros on the right hand side. And with that condition, the numbers that we will always come across are these numbers only. So you will see you have 8 bits of address mask. One octet has 8 bits. So you will have all ones on the one side, all ones, all ones, all ones, all ones, all ones, all ones. And if you convert these numbers into their respective decimal format, you will get these numbers only. And if you choose any other number other than these, you will find an interleaving ones and zeros. So that means if I write 255, that means this is all ones. Okay, all ones over here. Okay, then I need to choose a number where it should start with 1. It should start with 1. So it can be 128, 192, 224. It can be any other number. Let's say if I use 129, for example, if I use 129, it will start over here. But 1, 2, 3, 4, 5, 6, 7, 8, I will have 1 over here. Okay, and if I write this as 0.0, okay, 0, all zeros over here and all zeros over here. Now for a networking device, as I said, it tries to find out the network part through the number of ones and the host part through the number of zeros. Over here, it finds out that, okay, this is a network part. Then suddenly it sees, okay, this is a 0. That means this should be a host part. Suddenly there is a 1 in between. How can this be a network part? So the networking device is confused. Now, which is a network part, which is a host part? Because now it has interleaved ones and zeros. So the condition is that you cannot have interleaved ones and zeros in an IP address. That is why it is specifically chosen. The numbers that are specifically chosen are these numbers, where all the ones are on one side and all the zeros are on the other side. And that is why you will always see numbers like 255.255.224.0. So this is all ones, then 224 is three ones and all zeros. So 11111, then 123 ones, then after that all zeros. So for a networking device, all the ones will correspond to the network part and all the zeros will correspond to the host part. That is why it is very strategically chosen numbers. Clear? Any question?
No, it's
Of yeah, of why do we choose these numbers? All right. Now, moving on with this. Okay, let's try to understand few terms when we are understanding subnetting. Okay, when we are understanding subnetting, let's try to understand few terms as well. Okay, okay. So few terms that we have to understand is that the number of ones, okay, the number of ones in an IP address mask, okay, in an address mask, okay, total number of ones, total number of ones in an address mask, in an address mask is also called as prefix length. Okay, it is also called as prefix length. Okay, or in short, P. Total number of ones in an address mask is also called as prefix length or P. Okay, then the network bits, total number of network bits or network octet bits. Obviously, it's denoted as n, or it's called as n bits. Total number of host bits. Host bits are called as h bits. Okay. Now, total number of, now a new term, subnet bits are also present. We'll denote that as S. We will denote that as S. Okay. Now, this S is part of this total prefix length as well. Okay. So, if I am writing an IP address mask as 10.1.2.3 with an IP address mask as 255.255.255.0, for example. Okay, so here, what will be the prefix length or the total number of ones in the address mask? We will have 8 ones over here, 8 ones over here, and 8 ones over here. So in total, the P is 24, right? The P is 24. Now, this P or this total number of ones will include the network bits as well, plus the subnet bits also. Plus the subnet bits also. Network bits and the subnet bits both will give us the total number of prefix length bits. All right, is this clear? Any problem understanding this?
Yeah, this part is prefix plus subnet bits. So that is
Network bits plus
is
subnet
an
bits.
example, this one. So 250. So what is the difference between this network bits and subnet bits? So we have
Yeah, yeah. I
255.255.255. That is the network bits. Then
yeah, yeah. I'll no,
then
no, no,
what
no,
is
no,
this?
no, no, no. 250. Okay, yeah, okay. Network bits. Now, what is this network bit? Let me give you that. I did not explain what is a network. Good question.
Okay.
Sorry. Thank you. Thank you for pointing it out. This network bit is your actual network bit based on the address mark, based on the IP address. Based on the IP address. This address belongs to class A, right? And how many network bits are there in a class A IP address? 8, correct? 8 network bits and 24 host bits is the default address mask, correct? So over here, as per your class A IP address schema, your network bits are 8 network bits. And in total, you have 24 network, you have 24 ones in that address mask. So how many subnet bits will be there? 16 subnet bits. 16 subnet bits are present in this address mask, which includes your 8 network bits and 16 subnet bits, totaling it to 24 bits of prefix length. Okay, so over here in this table, you will see this 1, 2, 3, 4, 5, 6, like this. These are nothing but your prefix length. Prefix length, or the number of ones, the number of ones in that number. Simple. So if I write 255.255.255.0, I can write this number or this address mask as /24 as well. /24 denotes the number of ones in this address mask. Here you have 8 ones, 8 ones, 8 ones. So /24 gives me the number of ones in this address mask. If I write 255.255.0.0, that means I can write this as /16, giving me 8 plus 8 number of ones, 16 number of ones. This is my prefix. If I just write 255.0.0.0 gives me /8. So for class A, /8 is your default address mask, /16 is your default address mask, /24 is your default address mask for class C. Clear? Any question?
This is clear.
Yeah. Now, if I write 255.255.252, for example, dot zero, like this, an address mask, what can I write as slash? So I have 8 ones over here, 8 ones over here, then 252. For 252, you have 6 ones. You have 6 ones. So 6. Okay, so 8 plus 8, 16, 16 plus 6, 22. So you can write this address mask as /22 as well. /22 as well. Instead of writing the whole address mask, you can just write the number of ones in that prefix. It will give you that value, /22. Next, if I simply write it as 255.192.0.0. Okay, so it will be 8 plus 2. 192 has 2 ones, 0.0. So giving us /10, /10 as the prefix length, as the prefix length. Okay, so P, or the prefix length, is the number of ones in that address mask. So in real time, you may see an address mask like this in the full form, 255.255.255 form, or in the slash form as well. In the slash form as well. So slash form is nothing but the total number of ones in that address mask gives us the slash value. Okay. Now, coming to our important part of understanding what is a subnet in an IP address. What is a subnet in that IP address? So, a subnet in an IP address is nothing but a subset of the whole network. A subset of the network. A subset of a bigger network is subnet. Okay, so for example, I take the example of 10.1.2.3. Okay, /8. I'll write that as /8. We know /8 means 255.0.0.0. Okay, this is our IP address and the address mask. 10.1.2.3, okay, /8, which is equivalent to 255.0.0.0. Now, as I said, subnetting means you're giving a subset. It is basically a subset of a bigger network. Okay, how many host octets are there over here? You have 3 host octets. Correct. Basically, 2 power 24 hosts you can use, but there is no need for 2 power 24 hosts. So what you do, you give away a subset of the host to someone else. You give away a subset of the host to someone else. And how do you give this subset to someone else? You give this subset of a bigger network to someone else by converting the zeros in the host part to ones. Again, you are giving away a subset of a bigger network to someone else by converting the zeros in the bigger network to ones, and then giving away that number of ones to someone else, thereby creating a subset or a subnet. All right. Now, meaning, if you are with me with that sentence, if you have heard that sentence very carefully, let me explain you what I mean. So 255.0.0.0 is the address mask, default address mask for 10.1.2.3. Because this is a class A IP address, the default address mask is 255.0.0.0. Again, I'm repeating the statement. I'm giving away a subset of the bigger network. Okay, instead of network, I should use the word host. I'm giving away a subset of the host part to someone else. And how am I giving away the host part to someone else? By converting the host bits. Host bits are denoted as zeros, and converting the host bits to network bits, that is 1. I'm converting them into 1. So if I convert 255, okay, this is 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. I'm leaving these zeros as such, 0, 0. What I'm going to do, as I said, I'm giving away a subset of a bigger host net part to someone else by converting the zeros. And how do I convert? Simply 1, 2, 3, 4, 5, 6, 7, 8. I will convert these zeros as ones as well. 1, 2, 3, 4, 5, 6, 7, 8, and keep them as such. 10.1.2.3. Simple. So instead of 255.0.0.0, now the address mask becomes 255.255.0.0. So what is happening? Now, instead of having 2 power 24 host, now previously I had 2 power 24 hosts. Now I only have 2 power 16 hosts. But I also have 2 power 16 ones as well. But in these 2 power 16 ones, not everything is a network part, because the borrowed, please listen to this statement very carefully, the borrowed or the converted zeros, the borrowed or the converted zeros are called as the subnet bits. The converted zeros or the borrowed zeros are called as the subnet bits. So originally, this is your network bit. This is your network bit. Okay, the borrowed zeros or the converted zeros, this is your subnet bits. This is your subnet bits. Now, if you add these two together, you get the P or the prefix length, which is now a /16. Earlier, it was a /8. Now it is a /16. But in this /16, 8 bits are the original network bits, and the rest 8 bits are the subnet bits, basically the converted bits. Clear? Any question understanding what is a subnet bit in an address mask?
Okay, this one is fine. Can we go to the 172, that example, and check similar to this?
Yeah,
How it,
the question one. You
yeah,
mean the
previously,
questionnaire, right?
previous example, sir. So 192.168 dot.
Okay, well, let
That
me
one.
give you some other examples. Okay, 172.16.2.3. Okay, now 255.255.255.0 is the address mask. As I said, you will find these address masks in real time as well. So this is your /20 4, correct? 8.8.8. Now the question is, find out the total number of p bits, total number of network bits, total number of subnet bits, and total number of host bits. This is what we have to find out with this IP address and the address mask combination. Okay. So p bits mean total number of ones. And we know that that total number of ones includes your network bits and your subnet bits both. So p bits is 24 because you have 8 ones, 8 ones, and 8 ones. 24. Okay. Now, out of this, how many out of this 24 bits, how many of them are network bits? This is a class B address mask. And we know that in a class B address mask, you have two network octets. So 8 plus 8. So you have 16 bits of network octets. That means the borrowed subnet bits or the converted subnet bits are 8 bits only. Right? So your network bit plus your subnet bits gives you 24, which basically is network bits is 16 and subnet bits is 18, gives us 24. Now, host bits, basically the zeros. Obviously, this is an 8-bit zero, so you have 8 host bits. Clear? Any question?
Yeah, this understood. So now we can do the here 250.0.0.0 also in this. So in that case, how will we get the like network
What
and
is the
this one?
sorry? What is the address mask you're saying?
No, now it will 255.0.0.0. So class nest we
255.0.0.0.
can use anything there. Right? So
Yeah, you
either
can use anything. Okay,
uh,
so over here again, this is a /8
slash it. Okay,
/8. Okay, and you have a
two two dot
172.16.2.3.
two or three.
Okay, 2.3. Now over here again, what will happen over here is the concept of subnet will cease to exist in such a scenario. In such a
Okay.
scenario, the concept of subnet will cease to exist because the default address mask over here is 255.255, but you're giving a /8 address mask.
Let's see.
So if your class network bit and your address bit are less, meaning, okay, so your class network bit, okay, if your network bit is you know higher than your address bit, then that's
Okay,
a
means
problem.
a network bit is higher than the final that one final what
Exactly,
network plus subnet bits to that.
exactly.
Okay.
Or I can say that instead of this, your p bits is less than your network bits. P is
P
/8.
okay.
P is /8. Total number of ones is /8. However, your network bits is n, that is 16. 8 is obviously less than 16. P is less than n. So over here, your subnetting will cease to exist. This kind of addressing will be treated as a normal classful address where 172.0.0.0 will be the network part. And it will start with 172.0.0.1, 172.0.0.2, etc. till 172.255.255.250. This will be a broadcast ID. It's a good, actually, it's a very good question. And you may ask, people may be asked this question in an interview as So when your p bits, your total number of ones is less than the network bits, then your subnetting cease to exist.
So this is not called subnetting. So we are doing still the
Here you
subnetting we are
cannot do a
doing.
subnetting. Here you cannot do a subnetting because the total number of ones is less than the actual class
Actual,
bits.
okay, yeah, actual class is 16. So this becomes
Actual,
less than
yeah,
the 16. Okay.
yeah. So your address mask bits is less than the actual class bits. So in that case, you cannot do subnetting. You just have to go with the normal classification of IP addresses.
Okay, that will become the main class full.
Classful address. It you have to treat this as a classful IP address rather than a classless IP. Clear?
Okay, yeah, clear.
Yeah. So I'll stop our class over here, and tomorrow, with continuing with this, we'll go ahead with the problems with subnetting, and then we'll move ahead with finding out the network ID and the broadcast ID for classless IP.
Okay, yeah, sure.
Tomorrow we will have same time.